7.3. Linear inequalities in two variables. So because we're dealing with inequalities, we're going to be graphing, and the graphs will be shaded. So we've done this already when we did our first 9 weeks work. So we're just reevaluating this. Again, if you're going to graph, the best form to graph in is slope-intercept. So it's going to remind us about changing the form of the equation or the inequality, but also remind us of some rules. So they give us an example here in this first one. 3x plus 5y is greater than or equal to 30. So if we're going to graph, we need to get y by itself. So the first thing we do is subtract 3x from both sides. That cancels. So we're left with 5y equals negative 3x plus 30. And then we're going to divide everything by 5. Now, here's where we need to remember a rule. There's a rule we learned that said anytime you multiply or divide by negative, you have to flip your inequality symbol. I forgot that should be greater than or equal to. Well, in this case, we do not flip our inequality symbol because our 5's here are both positive, okay? So we don't flip our sign, so we keep it greater than or equal to negative 3/5 x plus 6. So we need to remember that rule so we get the correct inequality, because it's going to determine how we shade. Now what we do is we graph. So this is our starting point. So we're going to go to 6. We're going to put our point. And then we are going to use our slope. So this means we are going to go down 3 and to the right 5. So I go down, these are by 2, so I go down 3 and then to the right 5. So 2, 4, and then 5 would put us right here. So I'm going to put a point right here. And then I could do it again and go down 3 and then to the right 5. And then I'm going to draw my line. Now, after I draw my line, I have to determine whether it's a solid or dotted line. Well, because this is a solid line underneath, then this also must be a solid line. It is y is greater than. Because it's greater than, that means I shade above the line. And then I'll put arrows on it. Okay, so as we continue with the terminology, this is referred to as our boundary line. This is referred to as the half plane. It's the area that's shaded here. So it says check solutions to see if they work. So at this point, you can take either equation. So you could take the original one, which was 3x plus 5y is greater than or equal to 30. Or you could take y is greater than or equal to negative 3/5 x plus 5, or sorry, plus 6, sorry. And then it's asked to check the points. Well, if we use the original equation, so I'll come over here and plug that in. So I have 3 times 0 plus 5 times 0 is greater than or equal to 30. So that all goes away. So I had 0 is greater than or equal to 30. Well, that's false. That means that does not work. So if we go back and look at our graph, I'm just going to draw a real quick representation. It was like this, shaded here. Well, here is the point 0, 0. Well, that's false because it does not fall into the shaded region. Whereas if I do the point 8, 8, so again, I could use the original one and plug 8 in like they did here. Do that, so that gives me 24 plus 40. Well, 24 plus 40 is 64. 64 is greater than 30, that is true. And why is that? Because the point 8, 8 would be somewhere up here, and that is in the shaded area. So being able to check points is very important. and the best way to check them is using the graph itself. Now, you can also use the calculator to help you graph. If you take the equation right here, put it in y1 equals, okay, there you're giving you another example, and then take the inequality symbol. This points to the right. Well, if you look right here, in this example, that box is kind of pointing to the right and up. Now, the reason it points to the right and up is correlating back to our graph. You shade above and to the right of your line. So the issue with the calculator is if you draw it on the calculator, it is always going to draw a solid line. Whereas if you, in this example, if you were to do this one right here and put it on the calculator, it's going to draw a solid line. However, because there's no solid line under it, that one should be dotted. So it should be a dotted line that you put on your graph. So there are some limitations to the calculator itself. So looking here at the example, you notice that the line is solid. The calculator can't distinguish this, but it will show you where it's shaded as long as you pick the right inequality symbol. So here's another example to work out. I'm going to skip and I'm going to go your turn problem. So I'm going to take problem number 3 and I'm going to change the equation of the graph to get y by itself. So the first thing, I subtract 3. So I get negative 5x minus 3. Now remember, that's a negative 1, so I divide everything by negative 1. Now again, because I'm dividing by a negative, I have to flip this inequality symbol. So that's going to become y is greater than, now, 5x plus 3. And really that's 5 over 1 because you want to think of it as slope. So what do? I go on my graph. I plot my y-intercept at 3. So again, these are going by 2. So 3 would be right there. My slope's 5 over 1. So I go up 5. So that's 1, 3, 5. And then go over 1. So 1 would be halfway, and that would be my second point. So then I draw my line. Now again, there is no solid line under it, so that means this one's going to be dotted. So I draw a dotted line here, put arrows on it, and then it's y is greater than. So what do? That means I need to shade above the line. So where's above the line? Above the line is actually right over here. So even though it points to the right, you're going above the line. Now again, you want to check points here. So I just pick a point. If you notice right here, the point 0, 0 is underneath. Okay, so if I put 0, 0 in the equation, so I'm going to take this one. So I put 0 in for y. I put 0 in for x. That means that just goes away. And then I have 0 is greater than 3. Well, that's a false statement. Well, that means that point right there should not be in the shaded region, which it's not. So now I pick a point that is in the shaded region. So this time, let's say we pick negative 4, 0. So I put negative 4 in for x and 0 in for y. And I work that out, and I get negative 20 plus 3, so that's negative 17, and 0 is greater than negative 17, and that point is in the shaded region, so that works. So it's a good idea to pick points and check them in the problem. So I'm going to give you a minute here, and you may want to pause the video to try number 4, and then you can check your answer. Okay, so this is what you should have ended up with. Here's our final equation in slope-intercept form. Here's the graph. Now, one thing I haven't talked about is, so again, any point in here would be a solution. So 0, 0 would work. Any point up here is not. What about a point that falls on the line? Say I picked a point right here. Well, because the line is dotted, it falls through the line, so it does not work. If the line were solid here, then it would be on the line, and that would be okay. It would work. So again, understanding the dotted and solid line is an important concept. So we continue on with this, just representing it in a real-world form. So I'm going to skip the problem equation. Okay. And I'm going to go, here they give you one with a table. I'm going to skip that one and go right to number 6 here, the your turn. We're going to read this and try to decipher the meaning. Ramona has $18 that she can spend on food for her dog. Dried dog food costs $5.50 per small bag, and wet dog food costs $2 per can. Write a linear inequality. So now this goes back to our previous lessons. Putting it in an equation, however, this one's an inequality. So we have two rates here. So we have $5.50 per bag plus $2 per can, and that I have $18 to spend. That means I can spend less than or equal to $18. So the difference is I'm not wanting to spend exactly 18. I can spend up to 18. So that becomes our inequality. Now, again, if you're struggling with this, you could replace B with X and C with Y and then do it. But we're going to go ahead and change the equation. So I'm going to get C by itself. So I subtract. So again, this whole idea of being able to solve equations, very critical. Divide everything by 2. Now, again, I'm dividing by a positive. So since I'm dividing by positive, I do not switch my inequality symbol. I leave it the same. So then that's going to be negative 2.75b plus 9. Okay, so then that describes how many she can buy. You could have used the original equation just to write an inequality, but if you wanted to graph it, then you'd want to put it in slope-intercept form again. So all of this is about being able to solve inequalities and being able to graph them and being able, again, to interpret word problems and their meanings. So we are going on page 329, numbers 1 through 25 odd. And pay attention to your graphs, such as down here, scale goes by 2, so make sure everything you do is by 2s. Pay attention whether or not you need to switch. Like in this case, I would be dividing by -4, so my inequality symbol is going to switch. Here I would be dividing by a +2, so that one would not switch. So as you graph, whether you use the intercepts or not, you need to understand which side to graph or to shade. That's the reason you want to change it to slope-intercept form.